All right, for these problems, we're going to use the definition of a composition, where if you're given two functions f and g, the composition of f with g is defined as this. This statement says, take the function g and put it within the function f. You're actually substituting it in place of this x here. So for this first problem, we're given two functions, and we're just asked to compute these 6 values, just to get some understanding from this formula. All right, so if we look at this statement here, what we're saying is g is going within the function f, and then we're going to put x equals 0 into this equation. So I look at it like this. We choose x is equal to 0. It then first goes through the function g. So, okay, we put 0 here. That means we put 0 here, and the answer is 5. We then take that new number 5 and put it into the function f. So that would be 5 squared, which is 25, plus 1, which gives us an answer of 26. It's just kind of nice to visualize the journey this original x value takes. And I write it like this. You start with x equals 0. It first goes through the function g, and again, we got an answer of 5. It's then this brand new number 5 that goes through the function f, which we said was you square and add 1, which gives us 26. So written this way, f composed with g means take this number, first put it through g, then take that new number and put it through f. So let's try that in b and c. These are a very similar idea. It's again like this one here. F composed with g of 5 means we take x equals 5 and first run it through the function g. So that's going to be 5 plus 5, which is 10. We then take that new number 10 and put it through the function f. 10 squared is 100 plus 1. The answer is 101. C, again, really similar. It's the same statement, right? It's f composed with g of -5. Again, we're taking x equals -5. We first run it through the function g, which gives us 0. We then take that number and run it through the function f. 0 squared plus 1 is 1. So these were the answers for the first 3 problems. Now, if you look at D, E, and F, they're really similar in that we're using 0, 5, and -5, the same as the ones that are here. But the difference is this is G composed with F as opposed to F composed with G. So if you think about how this works, we start the same way with, okay, well, x is equal to 0. But first, we're putting it through the function f, and then we put it through the function g, so we're reversing the steps here. So if we first put 0 into the function f, 0 squared is 0 plus 1 gives us 1. So the first step is actually going to go to 1. But now we take that number 1 and put it through the function g. G is defined as x plus 5, so 1 plus 5 is 6. So these two things are actually different. The order here matters. F composed with G is not the same thing as G composed with F. I think this might happen for the next two, but let's just check it out. Okay, this is start with 5. First, put it through F. Okay, 5 squared plus 1, that's 25, 26. Okay, we then take that number 26 and put it through the function G, and we get 31. Okay, yeah, that's definitely different than f of g of 5. And the last one, again, I'm going to take -5. I first put it through f. If we square -5, you get a positive 25. So actually, you again go to 26. So if you put that through g, you again get 31. So these are the answers for the next two. So there's nothing special about me choosing 0, 5, and -5. You could have picked any number you want and just gone through this process, but that brings us to this fact here. You can put any number you want in place of g. You can put any number you want in place of f. Their domains are all real numbers. If this is true, then the domain of the composition is all real numbers as well. So just said another way, you can put any number you want into this composition, and this process will never fail. You'll always be able to put a number in and get a number out. And I knew that ahead of time. In question 2, if you check this out, you can put any number you want here, any number you want here. So if we look at both of these compositions, their domain should be all real numbers. But just to be careful, in question 2, I first want to find f of g of x. So don't evaluate a number, but instead get a formula for this. All right, here's how this is going to work. F composed with g means you take your function f, and wherever you see an x, you substitute the function g. So for this to work, I start with my function f, and wherever I see an x, I'm going to put a parentheses. And then inside those parentheses, I put the function g, which is x plus 5. So this is actually a formula for f composed with g of x. So all I did was, I saw there was an x here, I set up parentheses, and I substituted the function with inside it, just like this. And that's the answer. You could simplify it, but I think that's good enough for what we're going to talk about today. Let's see. I can just look at this and note that, okay, clearly the domain is all real numbers because you can put any number you want in place of x. You can add 5, you can square it, and you can add 1. Let's compare this to g of f of x. I mean, it should be different. It should be a different formula because these numbers up here were different, but let's see. Okay, what this says is we're going to take the function g, and wherever I see an x, I'm going to replace it with the function f. So my function g is x plus 5, so it's x plus 5, but instead of x, I'm going to put x squared plus 1. I mean, this one's easy to simplify. The parentheses are not really necessary. You can add 1 and 5, but I'll just leave this as my final answer. And the thing to note is we found these two formulas. They're definitely different formulas, but more importantly, the domains are all real numbers. You can put any number you want in place of x here. So question 3 is really similar. It's just like if you have a more complicated formula, can we still find the composition and then determine what the domain of this composition is? All right, for starters, f and g, even though they're more complicated formulas, the domains are all real numbers. So that must mean whatever the composition is, if I want to figure out its domain, it's going to be all real numbers. And the actual formula, f composed with g of x. Okay, that means I go to f, I'll set up some parentheses wherever I see x's, and then replace it with this equation here. So that is 25 something to the 5th power minus 45 something to the 3rd power plus 1. And in place of all of those parentheses, I'll put the function g, which is 50x to the 100th plus x. And I just do that again over here. Now, I don't want to simplify this. I don't want to raise this to the 5th power or cube this and combine all terms. So again, I'm going to leave my equation so it looks just like this. But the thing to point out is, clearly just by looking at this thing, the domain is all real numbers. You can put any number you want in place of x and simplify this. All right, so for question 4, I think it'd be good to look at where things go wrong. If I look at f, I see that the function is x plus 2, and the domain is clearly all real numbers. And maybe I'll make a note of that this time. I'll say the domain for f is all real numbers. You can put anything you want in place of x. Now, for the function g, the domain is not all real numbers. In fact, there's exactly one number that you cannot put in place of x, and that number is 4. If you put 4 in place of x, you get 4 minus 4 in the denominator, which is 0, and you cannot divide by 0. So I'll just, again, make a note where, okay, for g, I'm not going to use 4, but everything else is okay. All right, so that addresses part A. The domain for f is all real numbers. The domain for g is everything but 4. Okay, let's answer part B. I want to figure out f composed with g and g composed with f. I'll start with f composed with g. So what this means is I take the function f, and wherever I see an x, I'm going to replace it with this entire function. So that is, I'll open up a parentheses and put plus 2 at the end and plug in my function like this. And that's it. This is my function, f composed with g. The thing to point out is the domain of this thing is all real numbers except 4. I can just look at this formula and note that if you try to put 4 in place of x, something's going to go wrong because you're going to divide by 0. So I'll put next to this here, x can't be 4. But really, this is not a surprise. If you look at this composition, you would first have to put a number in place of g, and since you can't use 4, that's why it's excluded at the end. But you can actually also see it in the formula. If you try to put 4 in place of x, you would get division by 0, which means it can't work. Let's compare this to g of f of x. Okay, so this means in place of this x, I'm going to substitute the function x plus 2. So that is 1 over x plus 2 minus 4. I think this is actually worth simplifying just a little bit. You don't need these parentheses. It's really just 2 minus 4. And this equation is 1 over x minus 2. So now, what's the domain of this function? I think this time 4 works. You would first have to put 4 into the function f, which you're allowed to do, but that generates a new number, which means, okay, it won't be 4, and therefore it can go into the function g. So in this example, I think 4 is actually okay, but there is exactly one number that you can't use, and that number is, just by looking at this formula, it's 2. So that's the domain of my function. It's every number but 2. So the reason 2 does not work is, if you take your function and you try to put 2 in place of it, you would first have to evaluate f of 2. F of 2 is 2 plus 2, which is 4, and we already decided that, okay, well, 4 is the number that can't go into the function, so like this won't work. That is the only number where this happens, and therefore we've answered this question. For the last one, question number 5, again, what's the domain of f and g? The domain of f is all real numbers. You can square any number you want. But the domain of g, that's everything except negative numbers. So everything from 0 to infinity. So this answers this first part. That should be an A and that should be a B. But next we want to determine both f and composed with g and g composed with f and their domains. So let's start with, how about f composed with g? So if you look at f composed with g of x, that means you take the x squared function and you're putting in the square root function like this. And the thing to point out is that the domain of this function has to be the same as the domain of the square root of x. The reason is numbers first go into g and then they go into f. So here the domain is all positive numbers and 0. But here's where you'd have to be a little bit careful. I mean, technically, if you square the square root, that's just equal to x. And this formula looks like the domain is all real numbers, but in fact it is not. It's only these values here. Okay, if you compare this to g composed with f of x, all right, now this is the square root of, and in place of x, I'm putting x squared. Now, what's the domain of this function? Okay, the domain here is, well, you can put any number you want in place of f. There's no issue here. Furthermore, since f is x squared, every number you get back is a positive number or 0, meaning that all of those numbers can then go into g. Here, I'm saying that the domain is all real numbers. But here you have to be careful. If you take the square root of x squared, it's tempting to say that it's equal to x. But we'll investigate a graph and note that it's actually the absolute value of x.